Lesson 13.3, Trigonometric Functions of General Angles. Now this table, this key concept frame here, shows us that we can find sine, cosine, and tangent and their reciprocals given a point, okay, and a point is a location on a grid on a Cartesian coordinate plane, and if we make a right triangle by dropping an altitude or a height to the x-axis, that right triangle can be used to find all our trig functions. Now we're going to go to a specific example here in a moment, and that's going to be where it's best made most clear. But there's one observation here, and that is that the values of x and y must be respected in terms of what quadrant it goes to. So if it's a negative x, we have to go left, and so on. The r, however, is always positive. Okay, and again, I'll show you the example of that when we get to our first example. All right, now if we take a look at this question, we have 8, negative 15. 8 to the right, negative 15 down. So we have 8 to the right, negative 15, that's why we went down. And then we have this radius, or hypotenuse, coming from the origin. We will need to find out what r is for us to get all of our 6 trig functions. To do that, we use Pythagorean. So we say 8 squared plus negative 15 squared will equal r squared. Now, r squared will equal, and 8 squared plus 15 squared is 289, I believe. We do the square root of both sides, and r is 17. So r is 17. That gives us 3 sides of the triangle, of a right triangle, where theta is the angle from the x-axis to the hypotenuse, and from that we can come up with our trig functions. So sine of theta, we don't know what the angle is, but we can find the ratios. Here's where we must respect the coordinate. So opposite is negative 15. We don't write 15 because if we said 15, we would put it up in the first quadrant, and that's where it is not located. So the negative 15 will put it in the proper quadrant for us. Over hypotenuse, 17. Cosine of theta is adjacent over hypotenuse, and tangent is opposite over adjacent. From those 3, we can do our reciprocal trig functions. And for tangent, it's cotangent, which would be the reciprocal. Cosine is secant, and sine is cosecant. And those are our 6 trig functions. Now make one little observation here, if you will. Opposite over hypotenuse, the sine, okay, this coordinate right here is 8, negative 15. I drew out a nice triangle, that's good, but even if I didn't, we'd know that 8 represents our adjacent side, our x side, and negative 15 represented our opposite side. The hypotenuse we had to calculate. Okay? Again, we're going to come back to this in a couple examples here. Next question, find the exact values of 3 trig functions. Again, any 3 that you would like. Now, 5, negative 2, or excuse me, negative 12, would still put us in the 4th quadrant. And we're looking for r. So r squared equals 5 squared plus negative 12 squared, and r squared will equal 169. Root of that will be 13. Now, since we can choose any 3, I'm going to do sine of theta, which is again negative 12, respect to sine, that puts it in the proper quadrant, over hypotenuse. And since I can choose 3, then I'm going to do the reciprocal of that, because it's just, I'm going to do cosecant because it's just the reciprocal. And I have 2 done right away. And then let's try cosine out of habit. Cosine is 5 over hypotenuse. And that's 3 trig functions. Now what if our terminal side doesn't land in a quadrant but lands on an axis? Now this presents an interesting problem, and hence we're going to look at the coordinates to figure this out. If this says that it's in standard position, it has a vertex at the origin, and it measures 180 degrees, that means it's going to be out here somewhere. We don't know how long it is, so I'm going to make this coordinate an unknown, but I do know that since it's on the x-axis, my y is 0. Now, since it's horizontal, just as if it were vertical, I'll know my radius length. It will be the same as the x, in this case, the x distance. So I'm going to say negative r. I say negative r because it went left, and that's the negative x values. I'm going to say negative r because the x value will be the same as the r value. Remember, of course, however, that the negative r puts you to the left, just like negative x would. Okay. But the r is still positive. Don't forget that. You have 3 things to think about: opposite, adjacent, and radius. The distance r will need to be positive. And from this, we can figure out our trig functions. Sine of theta equals opposite over hypotenuse. Now, the hypotenuse is r, units long. You don't have to know a length. The opposite side, if you remember on the other page, we said the opposite side is the y value of the coordinate. So the y value of that coordinate is 0. So our sine of theta will just be 0. Cosine of theta, and if you remember, we said adjacent was the x value, and the x value of that coordinate is negative r over the radius, or hypotenuse, r. That will give us negative 1. And tangent will be opposite, which was 0, over adjacent, which is negative r. Again, the y over the x, and that will give us 0. Now, at this point, I'm going to stop, and this will be the end of Part A.